Today we'll be discussing the first chapter of our course, which is the counting. All our daily transactions relate to counting. Let me give you an overview of the topics included in this chapter. First is the basics of counting. Subtopics are the product rule and the sum rule. Second is the permutations and the combinations. And lastly, the pigeonhole principle. This chapter tackles about combinatorics, which is a study of arrangements of objects, one of the important parts of discrete mathematics. We define also the word enumeration as the counting of objects with certain properties. Also, it plays an integral part of combinatorics. In solving different types of problems, one must know how to count. An example of this is our daily commuting, going to school, or any places. One must know to give the exact fare as well as the change if there is. In computer science, counting is used to determine the complexity of algorithms. Also, it is required in determining whether there are enough telephone numbers or Internet Protocol addresses to meet demand. Recently, it has played a key role in mathematical biology, especially in sequencing DNA. Furthermore, counting techniques are used extensively when probabilities of events are computed. Let's now proceed to the first topic, the basics of counting, which includes the product rule and the sum rule. In product rule, a procedure can be broken down into a sequence of two tasks. If there are n1 ways to do the first task, and for each of these ways, there are n2 ways to do the second task. Therefore, there are n1 and 2 ways to do the procedure. Example, there are 32 microcomputers in a computer laboratory. Each microcomputer has 24 ports. The problem now is how many different ports to a microcomputer in the laboratory are there. Now, the solution is there are 32 microcomputers multiplied by 24 ports, and that is equal to 768 different ports to a microcomputers in the laboratory. Succeeding slides are another examples for you to read and analyze. Next is the sum rule. One task can be done either in one of n1 ways or in one of n2 ways, where none of the set of n1 ways is the same as any of the set of n2 ways. Then, there are n1 plus n2 ways to do the task. Another example, there are 37 ways to choose a member of the mathematics faculty, and there are 83 ways to choose a student who is a mathematics major. Choosing a member of the mathematics faculty is never the same as choosing a student who is a mathematics major because no one is both a faculty member and a student. As a solution, we are going to apply the sum rule. There are 37 ways to choose mathematics faculty members plus 83 ways to choose students mathematics major, which is equal to 120 ways. The next example is also for you to read and analyze. That's all for today. Have a great counting day.